so that when we're making these architectural decisions, people are well informed and they can make good choices. We're going to constrain the amount of support and focus primarily still on JVM, but obviously this new use case of Node and Docker is pretty critical, and so there's a lot of energy going into supporting that. And then, of course, logically, we'd have to prioritize by impact with a finite number of people who can work on these types of things, and where possible, seek reusable solutions. Delivery is relatively generic, so you can probably support a wide variety of languages and platforms with delivery. So that's one example there. One other example is client libraries that are relatively simple can potentially be auto-generated. So you can create a Ruby version and a Python version and a Java version. So we're seeking those kinds of solutions. Again, this is one of those places where there's no one cut and dry right way to do this. Hopefully this is good food for thought if you're dealing with these kinds of situations. So let's talk about that last element now, change. What we do know is that when we are in the office, when we are making changes in production, we break things. This is outages by day of week. And lo and behold, on the weekend, things tend to break less. Here's the really interesting one by time of day, 9 o'clock in the morning, boom. Time to push changes, time to break Netflix. So we know that that happens. And so the fundamental question here is, how do you achieve velocity but with confidence? How do I move as fast as possible and without worrying about breaking things all the time? The way that we address that is by creating a new delivery platform. This replaced Asgard, which was our workhorse for many years. This new platform was a global cloud management platform, but also an automated delivery system. And here's what's really critical here. Spinnaker was designed to integrate best practices such that as things are deploying out into production, we can integrate these lessons learned, these automated components, directly into the path for delivery. In the pipeline we see here, it's using two things that we value highly. Automated canary analysis, where you put a trickle of traffic or some traffic into a new version of the code with live production traffic. And then you determine whether or not the new code is as good or better than the old code. And stage deployments, where you want to make sure you deploy, I'm getting the 5-minute sign. We want to make sure you deploy one region at a time so that if something breaks, you can go to other regions. You can see the list here of other functions that are integrated. And long-term, the production-ready checklist we talked about earlier is fodder for a whole wide variety of things that long-term should be integrated into the delivery pipeline. I'm cheating a little bit here because of time constraints. Luckily, I can. And I did a talk last year at reInvent that might be of interest to you if you really want to dig into how these functions deeply integrate with each other. How does the production-ready performance and reliability, chaos engineering integrate with Spinnaker and continuous delivery, monitoring systems, et cetera? So I would encourage you to check it out. Now I'm going to close this out with a short story about organization and architecture. In the early days, there was a team called Electronic Delivery. That's what, actually the first version of streaming was called Electronic Delivery. We didn't have a term streaming back then. In fact, originally we were going to do download and had a hard drive in some kind of device. And the very first version of the Netflix-ready device platform looked something like this. It had fundamental capabilities like networking capabilities built into the platform, functionality around security, activation, playback, and then there was a user interface. The user interface was actually relatively simple at the time. It was using something called a queue reader, where you'd go to the website and add something into your queue and then go to the device and see if it showed up. What was also nice is this was developed under one organization, which was called Electronic Delivery, and so the client team and the server team were all one organization, so they had this great, tight working relationship. It was very collaborative, and the design that they had developed, or that we had developed, was XML-based payloads, custom response codes within those XML responses, and versioned firmware releases that would go out over long cycles. Now in parallel, the Netflix API was created for the DVD business to try and stimulate applications, external applications that would drive traffic back to Netflix. We said, let 1,000 flowers bloom. We hoped that this would be wildly successful. It really wasn't. It didn't really generate a huge amount of value to Netflix. However, the Netflix API was well poised to help us out with our UI innovation. It contained content metadata, so all the data about what movies are available, and could generate lists. And it had a generalized REST API, JSON-based schema, HTTP-based response codes. It's starting to feel like a more modern architecture here. And it did use an OAuth security model because that's what was required at the time for external apps. That evolved over time to something else. But what matters here is that from a device perspective, we now had fragmentation across these two tiers. We now had two edge services functioning in very, very different ways. One was REST-based, JSON, OAuth. The other was RPC, XML, and a custom security mechanism for dealing with tokens. And there was a firewall, essentially, between these two teams. In fact, because the API originally wasn't as well scaled as NCCP, there was a lot of frustration between teams. Every time API went down, my team got called. And so there was some friction there. We really wanted them to be able to get that up and running. But this distinction, this unique services, protocols, schemas, security models, meant that, God forbid, you were a client developer and you had to span both of these worlds and try to get work done. You were switching between completely different contexts. And we actually had examples where we wanted to be able to do things like return limited duration licenses back with the list of movies that were coming back for the user interface. So when you click through and hit play, it was instantaneous, as opposed to having to make another round-trip call to do DRM. So because of this, I had a conversation with one of the engineers, a very senior engineer at Netflix, and I asked him, what's the right long-term architecture? Can we do an exercise here and go figure this out? And this was a gentleman named Peter Stout, and of course, very thoughtfully, the first question he had to me seconds later was, do you care about the organizational implications? What happens if we have to integrate these things? What happens if we have to break the way we do things? Well, this is very relevant to something called Conway's Law. Does anybody, I'm hearing some laughter, so whoever laughed first, tell me what Conway's Law is.
The relationship between your services will look like the relationship within your company.
All right, good. Here's the more detailed explanation. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. They're very abstract. I like this one a little better. Any piece of software reflects the organizational structure that produced it. Here's my favorite one. You have 4 teams working on a compiler, you'll end up with a 4-pass compiler. So Netflix had a 4-pass compiler. That's where we were. And the problem with this is the tail wagging the dog. This is not solutions first. This is organization first that was driving the architecture that we had. And when we think about this, this is essentially going back to this illustration we had before. We had our gateway, we had NCCP, which is handling legacy devices, plus playback support. We had API. This was just a mess. And so the architecture we ended up developing was something we call Blade Runner, because we were talking about the edge services. And the capabilities of NCCP became decomposed and integrated directly into the Zool proxy layer, the API gateway, and then appropriate pieces were pushed out into new, smaller microservices that handle more fundamental capabilities like security and features around playback, like subtitles and dubs and serving metadata. So the lessons learned here. This gave us greater capability and it gave us greater agility long term. By unifying these things and thinking about the client and what their experience was, we were able to produce something much more powerful. And we ended up refactoring the organization in response. I ended up actually moving on. My whole team got folded under the Netflix API team, and that's when I moved over to operations engineering. And that was the right thing to do for the business. Lessons learned, solutions first, teams second, and be willing to make those organizational changes. So I'm going to briefly recap. I have 0 minutes, so I'm going to go over just a couple of minutes, just so we can wrap up cleanly here. So microservice architectures are complex and organic, and it's best to think about them that way. And their health depends on a discipline and about injecting chaos into that environment on a regular basis. For dependencies, you want to use circuit breakers and fallbacks and apply chaos. You want to have simple clients, eventual consistency, and a multi-region failover strategy. For scale, embrace auto-scaling, please. It's so simple, and it's a great benefit. Reduce single points of failure, partition your workloads, have a failure-driven design like embedding requests and doing request-level caching. And of course, do chaos, but again, chaos under load to make sure that what you think is true is actually true. For variance, engineer your operations as much as possible to make those automatic. Understand and socialize the cost of variance and prioritize the support. If you have a centralized organization, and most organizations do, prioritize by impact to make sure that you're as efficient as possible. On change, you want automated delivery and you want to integrate your best practices on a regular basis. And again, solutions first, team second. There's a lot of technologies that support these strategies that Netflix has open sourced. If you're not familiar with it, I think a lot of people are, go check out Netflix OSS. And also check out the Netflix Tech blog, where there are regular announcements about how things are done at Netflix, how things are done at scale, announcements about new open source tools like Visceral, which is the tool that generated the visuals we've been looking at throughout. And I think we're out of time at this point. Do we have time for questions, or should I just take it out?
Outside if you can.
All right,
Thanks,
cool.
Josh.
Well, I pushed the limits. Thank you very much.
Thank you, everybody.